So, a Merry New Year to all. A quick sprint after a long break to semester. So looking ahead at the rest of semester one. So we've got this week and next week left in semester one. And I want to squeeze in exponentials and logarithmic functions into that time, because really that's the amount of time that we need. We need like 5 days, and that's going to give us about 5 days. Okay? So my plan right now is we will have, we'll intro things today, and then tomorrow there will be a short video for you to watch on the line, and then Wednesday we'll solve with logs and exponentials. Thursday we'll solve. Friday and the weekend we'll have a very brief formative, but I want to definitely get a formative going on this weekend. And then Monday of next week we'll have word problems, because after that then we will have next week, Tuesday, I'll open up I don't even want to call it a test for Unit 5. It's more of just a quiz. Okay? So there will be a quiz next week, Tuesday. Then Wednesday is going to be semester review. And then Thursday and Friday are going to be your final. So everything needs to be done by the 15th, by next Friday. Okay? So that's the day that everything needs to be done. Okay? 3 o'clock that day, grades are locked in for first semester. Okay? So if you have stuff that's out there that's missing, tests, quizzes, formatives, anything like that, homeworks, that should be done sooner rather than later, because we are at. What's up?
Is that for all classes? Next week Friday is the cutoff date?
Well, next week Friday is the end of the first semester, so yeah, I would assume that's for all the classes. That would be that way. So, because that's technically the last day of first semester. So, yep. So yeah, so we got that going on. Okay. So so things that have to be done yet this semester. You'll have a worksheet this week. Very short. Should take you 5 minutes to do the whole thing, but I'll give you plenty of time this week to work on it. A semester review packet, and a test, a formative, a test, and a final. So you got 5 things to do in the next 2 weeks. Okay? All right, let's dive into it. Exponential and logarithmic functions is our topic for the day today. And so just want to talk a little bit here. You don't necessarily have to write this down. I just want to talk a little bit about the difference between a linear function and an exponential function. Okay? A linear function changes by an equal rate of change, an equal difference over an equal interval. Okay? Or in an interval. Okay? So a line will always have the same slope. Okay? So it's always going to be, rise over run. It's always going to go up a certain amount and right a certain amount. And that will always stay the same forever and ever and ever, no matter which way you go on that function. An exponential function changes by a factor over the same interval. So instead of always adding 5, a linear function, you're always adding the same amount every single interval. So like adding 5, you would be multiplying by 5. And then that would continue to grow exponentially. Okay? So this is changing at a constant percentage rate. Not changing at a constant rate, changing at a constant percentage. And so exponential functions grow or decay. They can either get bigger or they can get smaller at a very large or at a very faster pace than a linear function. Okay? On a graph, it looks like this. Here's the difference between a linear function and an exponential function. Okay? A linear function would always continue to grow as t increases, so every bottom value, as we go up by 1, the y value goes up by 5. Okay? And so it would you get that line, you get that linear growth. Okay? Exponential, we've been living in an exponential curve since March. Okay? Everybody's talked about the the coronavirus growing exponentially. That's what an exponential function looks like, where it's growing faster and faster, or the cases, in terms of the coronavirus, the cases are getting more and more, but it's growing at a faster and faster rate, okay? Increasing much more rapidly. Okay? In terms of what the actual equations would look like for these two, this left one, a linear function, would look like y equals mx plus b. So in this case, it would be 5x plus 100. Started out at 100, grows by 5 every time, so that's y equals 5x plus 100. The equation over here looks a little different. It's y equals 100 times 1.05 to the t power, or to the x power, really. X there because it's more common. Yeah. Notice, and this is the key part here, notice where the independent variable, the x, is in the exponential. Okay? The variable is in the exponent. That's why it's called an exponential equation. Okay? Because the variable is now in the exponent. That's what makes it grow faster than just a steady, constant rate. Okay? So this is where I would start taking notes again. Okay? Exponential functions, we'll just use the basic type ones. Y equals a times b to the x power. That is the basic exponential function. Y is the output, the dependent variable. A is your initial value. The value at which, if you want to call it the y-intercept, we can call it the y-intercept, because it's the value when x is 0. Okay? B is your growth rate. If b is bigger than 1, it's going to grow. If b is between 0 and 1, it will decrease. Okay, so it'll grow. If b is bigger than 1, it'll decay if b is less than 1. But b can't be negative. B has to be positive. Okay? So the conditions on this one, b can't be 0 or 1, and b must be So that's exponentials. Logs base b of x okay. The left one is log. The right one is natural log. Natural log is log with a base of e, the exponential number. Okay. Here again, same rules for b. B cannot be 0 or 1, and b has to be, excuse me, bigger than 1. No, b has to be bigger than 0. Okay. Now, the wonderful part about these two is that these two, exponentials and logs, are inverses of each other, which is going to come into play on Wednesday, because that's how we solve either one. We have to change forms with it because we need to get it into the inverse form in order to solve it. So that's going to come into play on Wednesday. Okay? So, this is very important for you. You're going to need to know this. This is the key. This slide right here is the most important slide of the week. Yeah? To go from exponential form to logarithmic form, you need to follow this pattern. Okay? So if you're in exponential form, you're going to have a base, we call it b. You're going to have an exponent, and that's going to equal some number. Okay? To change that to logarithmic form, we would take the base, and that becomes the base on our log. The number that it's equal to is the argument of the log. That's called the argument position on the log. And that equals the exponent. Okay? Exponential form finds numbers. Logarithmic form finds exponents. Okay? That's the whole point of logs, is that it finds exponents. In both cases, come on now. There we go. We have, oops, I guess I can't get them in there. Let me move this one up. In both cases, hold on one second. Let me move this up too. But I had it all attached. In both cases, we have two rules. The rules are that b and the number, the argument, are both positive. And that b cannot be equal to 1. Our exponent can be negative. But if b is positive, if our base is positive, we will always have positive numbers. Okay? A positive number to any power is going to be positive. So that's why b and the number are always positive. Today, what I'd like to do is I would like to focus in on switching forms, because we're going to need to use that a lot this week. So if I rewrite this, if I've got the base to an exponent, And that is going to equal the argument, just another way of writing the same thing. That changes over into log of my base argument equals my exponent. Okay. Just another way of doing that. Okay. So if we're in log form, you will obviously see a log. That's how you know if you're in log form. You'll either see the word log or you'll see ln. Okay? Okay? So we're in log form, so we're on the right side. We want to switch over to the left side. So I'll color code these again. Okay? So 27 is my base. Oops, no, excuse me, I'm tap the bracelet in there. Wrong thing. 9 is my base. Just thinking exponential form. There for a minute. 9 is my base. 27 is my argument. And 3/2 is my exponent. So when I write this out then in exponential form, I'd have 9 to the 3/2 power equals 27. Usually on these, that's a true statement. 9 to the square root of 9 is 3. 3 cubed is 27. So that is actually a true statement. Yep. Base would be 7. Exponent would be 3. Argument is 343. So this written out in exponential form is 7 cubed is 340. Questions on those two? What I'd like you to do now is I would like you to change those two into exponential form. I get 4 squared equals 16 for number 3. And I get e squared equals x for number 4. Because natural log, you think about it as log base e. So it would look like that if we wrote it out in log form, but we just don't write log. We don't write log base e. We write natural log. Questions on either of those? Okay. Rewriting each equation now into logarithmic form. Okay. So now here my base is 7. My exponent is 2. And my argument is 49. So that would become log base 7 of 49 equals 2. Base is 5. Argument is y. Exponent is x. So this would become log base 5 of y equals x. And then tomorrow, what we're going to do is we're going to learn how to solve logs, or how to evaluate logs of different bases, different ways, so that when we use it on Wednesday, we can get answers. Yeah? Questions on those two? What I'd like you to do now then is I'd like you to take those last two, these two, and solve them, or excuse me, put them in logarithmic form. So this first one, we get log base e of 3 equals x. Okay? But log base e, this thing right here, that is natural log. So we really write that one as the natural log of 3. Okay? Log base 8 of 4 equals 2/3. Okay?
Would it be wrong if you left it as like log e?
Yes,
So every time you log e, it's equivalent
it's
to
natural log. Yep.
Okay.
Yep. 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 So, couple of things. First off, what can we do now? We can do numbers 1 through 4. I believe it's 1 through 4. Yep. Numbers 1 through 4 on week 17 worksheet, which in-personers I'm about to hand out to you. Onliners, I'm about to post it online. Okay? So we can do that. We can, missing work, anything that's missing or needs to be fixed. And remember, that is a hard deadline on the 15th. Okay? That's nothing is going to change your grade after your semester grade after 3 p.m. on next week Friday. So if you have some things that are missing, get it done by then. Okay? Also, what I am going to give out today to the in-personers, Group B, you'll get it next week too, is the semester review worksheet if you wanted to start working on that also. Okay?